sorry, let me try that again. I think I was muted. So this is a lesson on 7.5, using an elimination strategy to solve a system. We've looked at graphing, we've looked at substitution, so this is the last way. In this way of solving system, one variable is eliminated by adding the equations together. So when we add two equations, you basically add all parts of them. You add like terms. So x's with x's, y's with y's, constants with constants. Okay, so you line them up, one right underneath the other, and we're looking for one of the variables to eliminate one another. Now, sometimes you'll be lucky and that will be given to you. So here, if we look, we have negative 3y and plus 3y. Negative 3 plus 3 is 0. So those are actually going to cancel out because they're equal to 0y. So when I add these, 2x and 5x is 7x. The y's canceled out. 15 plus 27 is 42. So I end up with 7x equals 42. Then I can easily solve for x by dividing by 7 and getting 6. Then, once I know one of the variables, I can put that into one of the original equations. So if I go to 2x minus 3y equals 15, I put 6 in for x. I'm going to get 12. I'm going to minus 12 from both sides and get negative 3y is equal to 3. I would divide by negative 3 and y would be negative 1. So my solution would be 6, negative 1, and I could verify that for both equations. I'm going to skip that for right now and get straight into example number 1. Now they started off simple here, and again, given us a variable that's going to automatically cancel out. 4 plus a negative 4 is 0. That cancels out. So what I do then is negative 5 plus a negative 3 is negative 8. And 14 plus a negative 10 is 4. I divide by negative 8, and y is going to be negative 1/2 or negative 0.5. I then take that y number and I put it back into one of the equations. Now, it does not matter if you use the first one or the second one. You'll get the same answer. Because remember, we're trying to find that coordinate point that works for both equations. So I'm gonna just go ahead and use the first one. So 4x minus 5 times my y number is equal to 14. So this becomes 4x plus negative times a negative is a positive. So plus 2.5 is equal to 14. I'm gonna minus 2.5 from both sides. 4x is going to equal 11.5, and I'm going to divide by 4, and x is going to equal 2.875. So my solution is 2.875 and negative 0.5. I'm going to verify that. So 4 times 2.875 minus 5 times negative 0.5 gives me 14. So that works. And then negative 4 times 2.875 minus 3 times negative 0.5 is negative 10. So I punch that in my calculator. And I get negative 10. So I know that that solution is correct. All right, now here's one that's not set up with you. Solve the following system by eliminating. So right now I have a 9x and a 25y, and I have a 3x and a 10y. So you have to think about how can you manipulate one of those so that one of the variables will cancel each other out. Well, I know that 3 could easily become 9. Now remember, we are adding these equations together. So in order to eliminate 9, a positive 9, I would have to add a negative 9. Okay, so think about that for a minute. I have to add a negative 9. So the only way to change a 3 into a negative 9 is by multiplying it by a negative 3. 3 times negative 3 will be negative 9. When I multiply, I have to multiply every term in the equation because I have to keep it equivalent. I can't just change one term. I have to do this to all of them. So this is going to become negative 9x minus 30y equals negative 9. I changed the whole thing. And now I'm adding to it that first equation. And when I do this, 9x plus negative 9x is 0. They cancel out. That's what I want to happen. Those are gone. So negative 25 plus negative 30 is negative 55y. And negative 13 plus negative 9 is negative 22. So I divide by negative 55, and y becomes 2/5 or 0.4. If you want to keep it as a fraction, you can. So I'm going to put that back into an equation now. 9x minus 25 times y equals negative 13. So I have 9x minus 10 equals negative 13. I'm going to add 10 to both sides. 9x is going to equal negative 3. I'm going to divide by 9, and x is going to equal negative 1 over 3. I'd like you to keep that as a fraction. If you are writing it as a decimal, you have to show that it's negative 0.3 repeating. Okay, so when we our solution is negative 1/3. I'm going to write 2/5, or you can write 0.4. And now I'm going to verify. So 9x negative 1/3 minus 25 times 2/5 equals negative 13. Now, when you're punching this on your calculator, grade 10s, if you don't know how to work a fraction button, you can go 9 times, and then in brackets, go negative 1 divided by 3. Close that bracket. Minus 25 times, open up that bracket, 2 divided by 5, close the bracket. And you should get negative 13. And the other one, 3 times 2/5 plus 10 times negative 1/3 equals 3. So 3 times 2/5 plus 10 times negative 1/3 is not 3. Let me pausing to see where I went wrong. Okay, I'm back. I tell you, it's a lot easier to have students that can tell me where I went wrong instead of having to figure it out myself. I put the numbers in the wrong spot. I put the y number in the x and the x number in the y. So it should be 3 times negative 1/3 plus 10 times 2/5. Then you will get 3 on every side, on each side. Okay? Solve this linear equation using elimination. So again, you have to look at what you want to change. Why didn't my screen move with me? There we go. Okay. You have to decide what variable you want to eliminate. Do we want to eliminate the x's or the y's? In this situation, it could work. I could change these x's so that one's a positive and one's a negative of the same number. So I'm thinking 15. I could modify these equations to get a positive 15 and a negative 15. I could also modify the y's there's a common number there of 12 to get one a positive 12, one a negative 12. I'm going to show you both. So if I wanted to eliminate the x's, I would change this first equation by multiplying it by 5, which would become 15x minus 20y equals 35. I would then multiply this equation by negative 3, and it would become negative 15x plus 18y equals negative 24. If I did that, these x variables would eliminate. Now, the other thing I could do is change it so that I could eliminate the y variables. So the first equation, I'm actually going to multiply by 3, and I would get 9x minus 12y equals 21. And the second equation, I would multiply by negative 2, and I would get negative 10x plus 12y equals negative 16. And you can see in that case that the y's would cancel, okay? So over here, I would get negative x is equal to 5. I would have to then divide by negative 1. So x would be negative 5. And over here, if I had done eliminating the x variables, I'd get negative 2y is equal to 11. And I would divide by negative 2. And y is negative 5.5. Now keep in mind, grade 10s, that you would either do this or this as your first step. You're not going to do both of them. I'm just showing you that there are 2 different possible first steps. Then once you do one of them, so let's say I had done this, then I would use that y variable to solve for my x variable. So I would go 3x minus 4 times negative 5.5 equals 7. Notice how I went back to the original equation and not the equation that I had manipulated. So 4 times 5.5 is 22. So I'd get 3x plus 22 equals 7. I'm going to subtract 22. 3x would be negative 15. And dividing by 3 would give me an x value of negative 5. So my solution is negative 5, negative 5.5. Now, had I done this as my first step, I would then take that negative 5 value and put it back into one of my equations and solve for y. Okay, so if I verify now, I've got 3 times negative 5 minus 4 times negative 5.5 is equal to 7. And I get 7 on both sides. And 5 times negative 5 minus 6 times negative 5.5 equals 8. And I get 8 on both sides. So that's how I know my solution is correct. Alrighty, so here is one with fractions. I'm just going to delete that. We're going to do this using our fractions. So use an elimination strategy to solve this linear system. Actually, maybe I shouldn't have deleted that box. The easiest way to do this, you're going to end up with fraction answers in the end. So this might seem like a little bit too much work, but if you get rid of the fractions first, it's easier to look at how to eliminate whole numbers. So to get rid of these fractions, I multiply by a common denominator. Common denominator between 3 and 2 is 6. So I do 6 times 2 divided by 3. 6 times 2 is 12, divided by 3 is 4. So instead of 2/3 x, that becomes 4x. 1 times 6 divided by 2. 1 times 6 is 6 divided by 2 is 3. So that becomes a 3y. And 4 times 6 is 24. I'm multiplying all the terms to keep that equation equivalent. Okay? Here I'm going to multiply by 4. So 4 times 1 is 4 divided by 2 is 2, so that's a 2x. 1 times 4 is 4 divided by 4 is 1, so that's a 1y. You don't have to write the 1 if you don't want to. And 5 times 4 divided by 2 is 10. Now again, we're going to manipulate one of these equations so that something will cancel out. I personally am going to choose to multiply this by -2 so that my x variables will cancel. When I do that, this is going to become -4x minus 2y equals -20. So I line these up. 4x minus 3y equals 24, minus 4x minus 2y equals -20. These cancel out. I'm going to get -5y equals 4. I'm going to divide by -5, and y is going to equal 4/5, -4/5. Okay? Then to solve for y, I'm going to go back to an original equation. So 2/3 x minus 1/2 times -4/5, that was my y value, equals 4. Multiply fractions top by top, bottom by bottom. A negative times a negative is a positive. I'm going to subtract 4/10. So 2/3 x is going to equal, now 4 as a fraction over 10 is 40/10. So 40/10 minus 4/10 is 36/10. And now I'm dividing by 2/3. Divide by 2/3. X equals, keep it, change it, flip it. Okay, I can reduce the 2 with the 36 by dividing by 2. And so 18 times 3 is 54/10, which is 5 4/10, which is 5 2/5. So my solution is 5 2/5 and -4/5. Alrighty, here's a full-fledged question. So we even have to make our equations. Melody surveyed the 76th grade 10 students. So we're gonna let x equal something and y equal something. So we have to figure out what the two things are that we are talking about. Melody surveyed the 76th grade 10 students in her school to find out who played games online. 1/4 of the girls and 3/4 of the boys said they played online games. Remember I said sometimes you need to look towards the end, how many girls and how many boys. So there's our two things. So let's let x be the number of girls and y be the number of boys. Now we need to create our two equations. There were 76 grade 10 students in total, so the number of girls and the number of boys equaled 76. 1/4 of the girls and 3/4 of the boys said they played online games with someone over the weekend. 39 students played online games that weekend. So 1/4 of the girls, so you can write that as a fraction or as a decimal, 1/4 of, remember of means multiply, 1/4 of the girls and 3/4, again, either written as fractions, so 1/4 of the girls plus 3/4 of the boys, or 0.25x plus 0.75y is 39 students. Okay, so we're using elimination. We want to try and eliminate one of these variables. So I personally am going to multiply this one by negative 0.25. So then I'm going to get negative 0.25x minus 0.25y is equal to 76 times 0.25, which is negative 19. And I'm going to add to that the other equation, which is a positive 0.25x plus 0.75y equals 39. So when I add those, these cancel out, which is exactly what I want to do. They eliminate. Negative 0.25 plus 0.75 is 0.5y, and negative 19 plus 39 is 20. Then I'm going to divide by 0.5, and y is going to be 40. So I take that, substitute it back into one of my equations. I'm going to go back to the easy one. So if x plus 40 is 76, we subtract 40 from both sides, x is going to be 36. So my solution is 36 and 40. The last step to these questions is to verify. I know I didn't verify on the last one. I apologize for that. So x plus y equals 76. So 36 plus 40 is definitely 76. And 0.25 times 36 plus 0.75 times 40 equals 39. I get 39. So this is a word problem. Were 36 girls and 40 boys. All right, that is the end of 7.5. I will list the questions for you to complete on the assignment page.